introduce our next speaker, who is slightly, less attractive, less funny, all the stuff in me that I've said a couple times. And I first met our next speaker in 2017 in Boston at a sports analytics conference. Everyone knows who I'm talking about, but I'm not going to say his name yet. But after the speaker gave his talk, I waited patiently after like a flood of people went to ask him questions and get his autograph and all these things, to ask my own question. And it turned out like 6 hours later, all of a sudden, we were still talking and having a conversation. And I bring that up kind of just to talk about the type of person that he is, the personality. I think anyone who's gotten to know him at all has come to know him as just a really genuine, caring person. Whether it deals with, a little bit of over-enthusiasm for the R language, which actually isn't possible, and being willing to like help each other out, build the community, whether it's with R or in life or with his family. He just keeps revealing himself to be a very special person. And he's certainly a very special friend who's meant a lot to me over the last 5 or 6 years that we are here. So I'm not going to talk any longer. I'm just going to ask everybody's favorite R guy, Jared Lander, to come to the stage.
Well, thank you, everyone. I'm very excited to talk to you today about deploying R and friends into a secure environment. So we're going to talk a little bit about what that means, what you need to consider, and like how you might go about it. So first, what are we actually talking about? What do we talk about when we talk about deploying R in a secure environment? It means mostly getting in the hands of people who want to use it, R and Python and maybe Julia, and their associated packages, like you want dplyr and ggplot. But you're not just going to use R, you want a code editor to work with it. You might want RStudio or Jupyter or VS Code. And if you use Posit Workbench, then you get all three of them right in there. But now you also want your add-on packages, so you might need a package manager. Now, this is not a sales pitch for RStudio, but since we use R tools and data science tools, there's going to be a lot of RStudio in here. You need a package manager. You might use RStudio Package Manager, or you might use Artifactory. And you could host CRAN packages, PyPy packages. You could host Git packages. And you probably might also, in a secure environment, want Linux packages for either like a mirror of apt or rhel. Please use apt. It's a little easier for data science, a lot easier. And if you're publishing, you want a publishing platform like Connect to get your Shiny apps up, or your Markdown or Quartar documents, or Jupyter, or whatever. And there's a lot of tools we can talk about. We will focus on RStudio, Posit, but the idea is the same for all the tools you might be putting up there. All right, so I'll talk about a little bit of other tools a little bit, but the idea is the same. So what do we deploy these tools on? Where are they going? There's a few options you might have. You might do on-prem bare metal. And if you get bare metal, you're really lucky. You're going to get raw performance. And that's really awesome. A little rare, though. Not too many people get bare metal anymore. A little more common is an on-premises VM. This has a lot of nice advantages. If you're ever afraid you're going to screw it up, you can just make a backup of it and then like, hey, go break it. It's fine. Well, not fine, but it's better off if you make an image. Plus, you can resize. You want more RAM. You want more processors. You got it. Also common is a cloud VM. And let's be honest, that mostly means AWS and Azure, maybe means GCP. I would love to see some people use DigitalOcean. I would love to see that get more traction, but you might use a cloud VM. Or you might be installing into a Kubernetes cluster. It's so hot right now. Usually, it's a managed Kubernetes cluster. EKS or Azure Kubernetes or GCP or DigitalOcean or Linode or Paperspace or whatever cluster you want to use. So we know we're going to deploy in one of these 4 types of spots. So then we have to ask, how locked down are they? How accessible are they? This means different things to different people. So there's a few different options. Maybe you have your tool exposed to the public internet. Anyone with the URL can access this tool. That's a setup we have seen. But you better make sure you have really good authentication if you're doing that, because it's open to the public. A lot more common is that you have to be inside your network, the left side of this image. You have to be either physically in the office, or you have to be VPN'd in to even reach the tool. And you see this a lot. It's never a good VPN like WireGuard, though. It's always some commercial VPN that just had a backdoor disclosed the previous week that hasn't been patched, right? But, we deal. I wanted to put an image of NordVPN, but I didn't want to be that snarky. But you need to have some sort of access to the network to even see the tool. But the key takeaway here is that the machine you're installing on has outbound internet access, and that's really important, as opposed to our next environment, which is air-gapped. This is two types of air-gapped. This is a type of air-gapped environment where the right side has no outbound internet connection, but it can talk to a different network that does have an internet connection, and that will be very important. And that's opposed to this version of air-gapping, where the right side network has no internet and no access to any network that does have internet. It is completely isolated. And we're going to focus on these air-gapped scenarios today. So who is doing this? What types of organizations are air-gapping or various levels of security? Pretty much everyone these days. Banks, hedge funds, insurance companies have been doing it a little longer than others, but pharmaceuticals and hospitals really care about this. Manufacturing, even consumer goods are doing this now. They're taking it seriously. No one wants to be breached. And of course, the government is doing this. They care about security. So how do these organizations know that they can trust us as an outsider to do this? Who are we? So for industry, and this is like private and public companies, they might put us through private background checks like Sterling. They might make us take drug tests. They'll put us through their training, like their cybersecurity training, their insider training. You get the idea. They might put us through a bunch of different training programs to make sure we're up to their snuff. Now, government, they have their own background checks, various levels of clearance. Public trust for most agencies, but if you're doing intelligence or defense, secret, top secret as such. And it's not a hierarchy. Just because you have top secret doesn't mean you have public trust. You would need both. Same forms, different timeframes, but you need to go through a process twice. And of course, their own training, which is remarkably similar to the industry training of different cybersecurity, insider threat training. They're all getting it from the same vendors, it seems. So now that they trust us, how do we access these machines? How do we do our job? Well, if you have the first type of air-gapped network where it can communicate to another network, a little bit easier, we can SSH into their network, the exposed network, and then through a bastion box, a jump box, get into the air-gapped network and work of it in there. Maybe it is a virtual desktop in a browser, various ways to get in. But if you have the more air-gapped network, I think that's the technical term, more air-gapped, we can't SSH in. We need physical access to the network, often meaning we're sitting in a cold room with no windows. And we certainly can't use our own equipment like this person is. We'd have to be using equipment from that company. All right, so we're inside the network. It's time to deploy. The biggest thing I want everyone to remember from this is that we're going to use Docker for everything. Everything goes inside Docker. Everything's better. So for our stack that we're talking about, we're going to talk about Workbench, Connect, Package Manager, Postgres, and Nginx. We find that gets you really far along the way. So we need to build a Docker image for each of these pieces of software separately. So for Workbench, we need to install R, maybe Python, the basic packages we want everyone to have, Linux system libraries, very important, and of course, Workbench itself. And you need to mount volumes for the home directory so users can save their work somewhere, and for configuration files. Then you need to configure the authentication provider, connection to databases, connection to metadata databases, a default R package repo, and what port you're going to listen to, and maybe your Linux repo. For Connect, largely similar, you need R and Python, basic packages, system libraries. You need to install Connect itself, and you need to mount a volume for where the Connect content is going to be stored. That needs to live on disk and be persisted somewhere. And of course, you need to configure, very similar to before, authentication. We're going to get into that. Connection to databases, metadata databases, what URL you're going to serve it on. And you need to set it up with you don't need to, you should, in a good ideal world, set up an email server. You don't always have that option though. A lot of places are like, nope, no email for you, which you can live without. Then for Package Manager, R and Python, notice a pattern here, system libraries, Package Manager. And then you need to find a way to have it listen on a certain port. If you're using Git packages, you need to find a way to authenticate against those Git packages, either SSH or HTTPS. Maybe you have Git on the secure side. There's all these considerations, but you need to tell Package Manager how to get there. Now, Postgres. What are we using Postgres for? This is not Postgres for data for the data scientists to use. All of our software we've talked about so far use Postgres as a metadata storage. So you need a Postgres container for each of those pieces of software. So you need to install Postgres in the container, you need to mount the storage directory, and you need to configure it, mainly the listening port. You can have one container for all three pieces of software, but it's better to have a separate container for each just to keep things really separate in case you want to blow something up. Happens a lot. It's like unplugging and replugging. And then you need some way to route traffic around to all of these pieces of software. So you install Nginx, and you configure it to know what URLs are going to what services, how to deal with security escalation. If someone says HTTP, you want to bump that up to HTTPS. But oh no, you're using HTTPS, so now you need SSL certificates. Ever try using a self-signed cert? It's really painful. So you need some way to deal with all of that. So a lot of things need to be configured. But let's say, we'll get to that in a second, now that we have our images built, we're good to go, right? You need to do vulnerability scans. You need to make sure the containers are secure. If we're handing this to a customer, we want to make sure it's trustworthy. So you're going to scan every single image, and you often do this with OpenVAS or Nmap. There's various ways, but those are probably the two most common ways we would scan an image. And then you're going to know about CVEs, the common vulnerabilities and exposures. Some of them we can't do anything about. There's a CVE in Postgres. We can't patch Postgres, but we need to make sure the client is very aware of any vulnerabilities that might be in there. And now, if we can change things, which is ideal, it's time to harden the images. Need to make sure these things are as locked down as possible. So you're going to remove any unused services. If you're not using a service, why is it in the image? You're going to close any unused ports. And then you want to avoid packages that make internet requests. They're sneaky. The GERT package, which is a Git interface, at installation time tries to reach out to apt and install a Linux package if it's not already there. That can really wreck your day. Other packages like Arrow try to reach out to the internet and install Arrow. Luckily, if you use a pre-built binary, you can install it right in the system and you're okay. But Torch tries to install libraries at load time when you say library of Torch. So you need to do it the first time, get an error, and then point it to local libraries, which hopefully are already in your image. So you need to have a back and forth about, hey, what packages are you going to use? Because if they say they want to use Torch after the fact, you're rebuilding that image. So a lot of things to think about. All right, so we have our images. They've been scanned. They've been hardened. We're happy. How do you get them onto the airgapped network? Well, the first network is where the airgapped network has access to an internet-facing network. That's easier. We get into the internet-facing network, and then we, via a jump box or a bastion, either SCP or rsync the images over to the other side. Then the other side, you could Docker run or Docker compose, preferably. Ideally, the secure side has a Docker registry over there. But then you still have to get the Docker images into that registry, but that's someone else's problem, right? But somehow you're getting the images over via SCP or rsync. But what do you do if you have the airgapped network where there is no outside connection? You turn to the sneaker net. This literally entails putting images on a hard drive or a CD or a DVD or a reel-to-reel tape. Yes, I've seen that. Well, I've seen people who've seen that. I've never seen it, but someone in this room I know has seen it. And then you physically move that over into the secure area, plug it in after telling the right people, and move it over into that secure network. You're literally putting things on hard drives and moving them. Does that sound efficient? No. Is it your only option? Yes. Well, you could use a DVD, but you know. All right. Then what about getting your R packages and Python packages over there? Well, actually, a bit of a misnomer. At least Package Manager can only do R packages in air-gapped mode right now. Theoretically, PyPy is coming soon. You would download the packages on the internet network, move them over either by SneakerNet or RCP, just like before. Okay, great. We have all the software over there. But we're talking about various types of commercial software, whether it's RStudio or Artifactory or GitLab. You need to activate licenses. You need to tell you have a right to use the software. Well, you can do an offline activation, which involves copying and pasting a bunch of code into a terminal and a website. Might not always work. Some of these pieces of software have license servers, where the software you have can communicate to a license server on the internet-facing network, and that communicates to the software vendor. Cool. If you can't do that, some vendors, not all, offer activation keys. So there's different things you might need to do. Great. Let's say we got our software activated. We now need to make sure our user connections are secure. And for this, we need to work very closely with IT. First, you might lock out people who are not on the network. It's like network access security. That takes care of the general population. But then we need to properly authenticate, maybe with two-factor authentication, and we need to deal with SSL certs. It's a headache because you need a certificate authority because you don't want to self-sign. And you need to get the certificates onto the end user machines. That's not our problem, though. So let's talk about authentication. You're most likely going to authenticate with Active Directory, SAML, Okta, or OAuth. If the client can't provide that on their secure network, we could package that up in its own Docker container to ship with all the other software to get it up there. So there's various ways you can do that. But if you're using a client auth, you need to work really closely with them getting the right config, because the number one problem with deploying software on secure or less secure networks is authentication. It always, and even maintaining stuff, that's always the biggest headache is authentication. So get it right, because it's a closely guarded secret that IT doesn't want you to have. So you have to develop a good relationship and make sure you have a good experience with them. So then you need to secure your connections to the database that the users will be pulling data from, because the data is really valuable. And this comes down mostly to best practices. You want your username, your password, other things stored inside environment variables, and you never want them in your scripts. Or better yet, you can use a service account for the database connection and set up a system-wide odbc.ini file. And that means all the users are using the same user account, which is good when you're deploying content. So imagine a user uses Kerberos, our third option, to forward their connect login information to the database. Sounds great, sounds more secure, right? When that employee leaves the company and you shut down their account, what happens to their content? That content no longer works. So it's a good idea to have a service account which Connect will use to hit the database. Now you have this beautiful Shiny app or a Flask app or a Plumber API. You need to make sure that is secure. So again, network access, make sure people can't get to network, and authentication. Make sure your publishing platform, whether that's Connect or any other product, has proper authentication. That goes back to working with IT and getting all the configuration for Active Directory or SAML or whatever set up correctly. So we flew through a lot of things there. And the key considerations that I want you to take away from this talk, things I want you to focus on, are the type of environment. Again, whether it was bare metal, on-prem VM, a cloud VM, or Kubernetes. That's going to make a difference in how you're going to approach this. Then, how locked down is the environment? Is it open to the internet? Do you have to be in the network? Or is it one of our air gap scenarios? Because that's definitely going to change your approach, especially the type of air gap. Then how are you going to move the files across? We talked about SSH tunnels and sneaker nets. Those are your best options, your only options maybe. You got to figure out what you're going to do. And you know what? It's better to plan that in advance and know what you're doing rather than finding it out along the way, especially if you have deadlines to hit. Then you're going to have to deal with your HTTPS. And notice I keep bringing that up. It really pains me. You have to deal with your SSL certs. Maybe you need to use CertBot. Plan ahead for this stuff. And then if you're going to use HTTPS, your customer needs to have not IP addresses, but URLs. You need to have that planned in advance. All these little things that just sort of add up that you need to keep adding in. It's not enough that the network's secure. You need to keep adding in all these little things. Then you have authentication. Again, this is the hardest part of anything we ever do with customers, getting authentication right. And that is not insurmountable. That has nothing to do with it being a secure network. Well, it is secure. It has to be you're securing it by putting authentication on there. But that's any type of network. You need to make sure you get that right, because that could make or break the whole installation. And if you do all of that in the right order, you'll be all set. So thank you.